Hi everybody. So today we're going to be talking about the Arduino microcontroller. So the Arduino is a particular type of a broad class of electronics known as microcontrollers. And what microcontrollers are essentially are little computers. And you'll find them in all sorts of different things from refrigerators, cars, air conditioners, even greenhouses. A lot of times will use microcontrollers. And what they do is they control things. And they consist of many different input and output terminals. So for this video, we'll focus just on the output terminals, and in some later videos, we'll discuss the inputs. So the output terminals, like they sound like, are outputs of the device. So for a lot of them, they're just going to be simple switches switching it either on or off. And when I say switching it on or off, what I mean is if you take a look at one of the channels, say this pin here, this pin can be either 0 volts, which would be off, or it could be 5 volts, which would be on. And you can think about it like light switches. You can take a light switch can be either flipped on, which would be like the 5-volt state for the microcontroller, or a light switch can be flipped off, which is like the 0-volt state for the microcontroller. And so you can use this to turn things on or off, hence you can control things with the microcontroller. I guess it's called a microcontroller because it's relatively small. Now, we can load various code onto the microcontroller to tell it when to turn specific channels on or off, how long to keep them on or off, and other things like that. So in order to do that, we're going to have to hook this up to our computer. So we've got a USB port here. It uses a standard USB AB cable, or sometimes you'll see these with printers. And so this plugs in here, whereas the other end is more of your standard USB connection. So this end will then go to the computer, while this end goes into the Arduino board. And so we'll be able to plug the board into the computer, write our code, upload our code onto the board, and then it will run. The other thing that the computer cable does for us is it allows us to give power to the board. There are other ways of powering the board. You can power it with a 9-volt battery using a 9-volt adapter. So this pin here would plug in here, and then this would go to the other end of a 9-volt battery, and you can run it freestanding, disconnected from the computer. But for the first several videos, I'll power it running off of the USB connected to the computer. There are some additional peripherals that come with the Arduino. You've got ground, 5-volt pins, and a few other little things like that we'll discuss in a little bit. What I want to do next here is I want to hook the Arduino up to the computer, and I'm going to load the Arduino Integrated Development Environment, or IDE. That's the programming interface on the computer that allows us to program it. So I'm going to pull that up, and we'll look at a basic program that's going to blink some lights, which is sort of the basic thing, just turning in a light bulb on and off. Okay, so now I've got the Arduino board hooked up to the computer, and I have the Arduino IDE opened on the computer, which is this code that we've got set up over here. Now, what we're going to do is we're going to make this code blink an LED that's built into the Arduino. So the built-in LED is right here, and it's connected to channel 13. And you can tell the channel numbers because there's printed on the board here, and also you can't see it in the camera, but on the side of the pin header there. So by using the built-in LED, we won't need to do any external wiring or anything like that. So let's go through the code and let me show you how this works. So like I said, this is the Arduino IDE, and there are two main loops. We've got the void setup loop and the void loop. And what happens first is everything in the setup loop is run one time when the Arduino is turned on for the first time, and then just the one time after being turned on. Then, after the setup loop is run, then the loop runs, and it'll run through all of these commands, and then it'll go back and run them again and again and again until the Arduino board is turned off. These double forward slashes, these indicate comments. So these are little notes you can leave for yourself that don't actually do anything when the code is run. So here, this comment's telling us that the setup function runs once when you press the reset or power the board. The reset button, if you did want to rerun the setup, is located right here. So you could push that button and then it would rerun the reset. So let's go into the setup function first. So the setup, everything is defined between these two curly brackets. We've got a comment here, and then this is the first real command. And what this command is doing is this is telling us the pin mode. And the different pins, you can set them to either inputs or outputs. Like I said, we're going to be focusing on outputs. I'm actually going to change that to 13. So what this is telling us is we're going to take channel 13 and it's going to be an output channel. All the commands have to be ended with a semicolon, so you'll notice that at the end there. And so this just sets up the pin. Now we'll go into the loop. This is what's run over and over and over again. Again, let me change this to 13 and 13 just to make things a little bit clearer. Now we've got the first output writing command, which is digital write. We're going to write channel 13 as high. So what this is going to do is this is going to turn channel 13 on. Remember, the channels can be either in a 0 volts or a 5 volt state. This corresponds to low or high. High is the 5 volt state, so it's like flipping the light switch on. So we'll turn the channel 13, we'll turn it on. That should light up the LED. Then we need to wait a little while before we do the next thing. So that's what this delay command does. The units are in seconds, or sorry, in milliseconds, excuse me. So 1,000 milliseconds is going to be 1 second. So we'll wait 1 second, and then we'll write channel 13 lower, turn it off. Then we'll wait a second, and we'll go back, turn it on, wait a second, turn it off, wait a second, turn it on, wait a second, turn it off, wait a second, so on and so forth. So this should effectively blink the light. So now that we've got our code set up, we need to load it onto the Arduino. So the first thing you can do is up here you can click the check mark to verify that your code is fine, and it says done compiling. There's no errors down at the bottom. So now I can try to upload it to the board with the arrow button up here. So compile the sketch, uploading, board will blink, and then I'll say done uploading. Now we can take a look and we can see that the onboard LED in channel 13 is blinking, just as we told it to. So it blinks on for 1 second, off for 1 second. I can do some other things with it. I could blink it, instead of 1 second, I'll go half a second. Then I'll re-upload it to the board, and we'll see that it's blinking faster. I can blink even faster than that. So let's see what it does here. So it'll upload. You can see it's blinking even faster. I can go quite fast, and in fact I can blink it on and off so fast that your eye can't tell that it's even blinking. And when I do this, what happens is to our eye it looks like the light is just staying on continuously. But what's happening, since it's on for half the time and off for half the time, it actually looks 50% dimmer. So this is one way that we can adjust the brightness of lights with simply turning it on and off. So we're flicking that light on and off, on and off, on and off, on and off. We're doing it so fast that our eyes can't tell that it's being flipped on and off. It just looks like it's on all the time. But what our eyes do pick up is that it seems to be dimmer. And you can adjust this even further. You could have it say on instead of on for 10 milliseconds. Say it's just on for 5 milliseconds and off for 10, and it'll look even dimmer still. You may or may not be able to see this on the camera, but I encourage you to try this on your own. Play around with that, and you can adjust the brightness in addition to the blinking. So this is how we would, so the basics of how we would set up the Arduino board, load code onto it, run the code. I'm going to reconfigure things a little bit and then show you how we can run an external LED, not just this onboard one. Okay, so now I've got, I brought in an external breadboard along with an LED and a resistor. What I've done here is I've connected the LED to the resistor so that the resistor will limit the current through the LED. I've got one end of the LED, the positive end, going to channel 10. I'm going to use channel 10 to turn the LED on and off. And then I've got the other end going into my negative power rail. The negative power rail is connected by the blue wire back to the ground connection on the Arduino. Now ground on the Arduino, that functions as our negative terminal of the battery. That's our return terminal. So current, conventional current will flow from channel 9, conventional current will flow from channel 10 through the wire, through the LED, through the resistor, and then back to ground, just like in our basic circuits that we've done with batteries. Now I have to program the Arduino to turn channel 10 on and off, and I can do the same thing I did with the built-in channel. Instead of channel 13 though, I'm using channel 10, so I'll change all the 13s to 10, and let's go ahead and let's blink it for 1 second on and 1 second off. Go ahead and upload this, and the light bulb, or the LED, is blinking on and off. And we can do the same thing. We can make it blink faster. So by changing the delay, we've made it blink faster. And we can again make it blink so fast by changing the delay to 10 milliseconds on and 10 milliseconds off that it will just seem like it is on continuously but dimmer. And we can do the same kind of things before. Let's make it really dim. Just leave it on for 1 millisecond and off for 10. And let's see what that looks like. And there it's really dim. So you can see how we can turn this LED on and off, make it blink and do things like that through the Arduino, through the controlling programming that we've uploaded into the Arduino. I'm going to do another setup here. What I'm going to do is I'm going to set up a row of LEDs, and we'll be able to blink them in different patterns, kind of like you might see at some of the Christmas light shows, where the lights, they blink on and off in different patterns. So we're going to kind of build something like that. So let me set that up, and I'll get back to you in a second, and we'll go through that code. Okay, so now I've got this wired up with multiple LEDs. So you'll notice a couple of things here. So once again, I've got ground and power coming off the Arduino, with the blue coming from ground going to the negative rail, red coming from 5 volts and going to the positive power rail. I've got my 4 LEDs. There's a current limiting resistor of 220 ohms for each of the LEDs. One end goes to the negative power rail, the other end goes to the negative side of the LED. The positive side of the LED goes to these yellow wires, and these yellow wires then run into the Arduino channels. And I'm using channels 8, 9, 10, and 11. 8 is for the red LED, 9 is for the blue LED, 10 for the green, and 11 for the yellow. So let's take a look at the code and see if we can understand what we've done and look at some of the modifications. So first of all, since I'm using pins 8, 9, 10, and 11, I need to declare those and set those as outputs. So we need to initialize that in the setup loop. And now let's try some things. So down in the loop, I'm going to do the basic blinking. So I'll write channel 8 high, I'll wait 1 second, and then I'll write channel 8 low, wait another second, and then this will repeat. So this should simply blink the red light on and off once a second. So let's change now channel 8 to channel 9 and just kind of go through the LEDs and make sure that we can turn on and off all of the LEDs. So there's the blue one. And there's the green one. And there's the yellow one. So I'm going to write both of these low just for a second, just to turn everything off. And let's see now if we can figure out how to make this kind of scroll through. So the light kind of runs this way and then this way and kind of repeats it over and over. So what I'll do is I'll start with channel 8. And I'm going to turn channel 8 on, so that'll be the red LED. I'm going to get rid of this last delay here, and I'm going to leave it on for just half a second. It works a little bit better. So that'll turn on the red LED, leave it on for half a second, and then turn it off. And once it's turned off, then I want to turn on the blue LED, leave it on for half a second, turn it off. Then I want to turn on the green LED, and then the yellow, and then I'm going to repeat this. So let's take a look at what this looks like here. So now it flashes on, and you can see the lights kind of cycle through. Another cool thing we can do is instead of turning the red light on and then turning it off before the blue, we could leave all of them on till we get all of them on, and then turn them all off and then start this again. So let me show you how we could do that. So instead of having the red light turn off, let's leave that on and then do the same thing for all of the other ones. So now you'll turn them on in succession, but when you turn the next one on, you'll just leave the previous one lit. I'm going to have to add an additional piece where I turn all of them off so that I can start this again. So actually what I'm going to do, let me make this a little bit more compact, and I'm going to copy this, and then I'm going to cycle through and turn them off. And I'm going to turn them off in the reverse order that I turned them on. So let's look at this here. So I'm turning channel 8 on, then channel 9, then channel 10, then channel 11. Then I'm going to turn channel 11 off, channel 10 off, channel 9 off, and finally channel 8 off. So let's take a look and see what this does. So you can see we can make some different patterns by carefully orchestrating the sequence of turning the lights on and off. And so play around with this a little bit, try your own patterns, some pretty cool stuff you can do, make your own little Christmas light displays if you like.